Alrighty, everybody. I just got our signal to start our planetarium show, so I'm going to be putting away our space trivia questions because now we're going to be heading into the unknown. Ooh. And good afternoon, everyone. Welcome to the Morrison Planetarium. Really quickly, I just want to introduce myself. My name is Christian. I want to be your planetarium presenter, and I'm very excited to have y'all here because you are my favorite place in this entire universe, which is the Morrison Planetarium. And the reason why is because everything that you see in purple right now is going to be one enormous screen. And also, folks, I want to let you know that I'm an actual person, and I'm not just a voice coming out of the walls, and I'm a person standing right behind you. Hey, how's it going, everybody? Don't hurt your necks. Look forward into the dome before you. That's where the whole show is going to be, as I just mentioned. I just want to let you know that I'm an actual person, and you are in for a special treat because you just came here to join me for my favorite planetarium show to do. This one's different from all the other shows that we've done here today, and this one's called Tour of the Universe. And with Tour of the Universe, this show's completely live, so you're going to hear my voice for the next 30 minutes as I free fly us through space. And what this show entails, well, we're going to be starting off pretty close to the Earth, and we're going to be zooming all the way out to the very edge of the observable universe. Hopefully, by the end of the show, you won't have an existential crisis of where we are in space, but I do need to forewarn you, we are pretty small in the grand scheme of things, so just a heads up. But before we get started with our show, I do have to go over some quick house rules just so that we're all on the same page and have an enjoyable time in here. First off, there's no food or drinks allowed inside. If you manage to bring any snacks, make sure those are put away till the end of the show. We want to keep the theater as clean as possible. We really do appreciate your help. Also, if you happen to have any cell phones, smartwatches, tablets, anything that produces really bright white light, now's the time to turn them off, deactivate them, put them away for the next 30 minutes, as these can be very distracting, not only for you, but also for the folks sitting behind you. Really takes away from the planetarium show. And also, folks, if you need to exit early during our show, you're more than welcome to do so. All we ask is that you exit the very top of the planetarium. That's where you're going to find the exits before, during, and afterwards. Although if you're a person that has trouble climbing the stairs, we understand the stairs are very steep. So once the show wraps up, just remain seated for a little bit longer. We'll have a staff member come by and escort you to a lower exit. And last but not least, folks, this show is quite immersive thanks to our 75-foot dome above us. If at any point during the show you start to feel overwhelmed, you start to experience motion sensitivity, there's a really quick and easy trick to ground yourself. All you got to do is close your eyes, take a few big deep breaths, and then your brain will remember that you're sitting in a planetarium in San Francisco and not hurtling across the universe, at least not more than the usual. Hee hee hee. With that being said, it looks like we're ready to go, so I invite y'all to sit back, relax, and let's begin our tour of the universe. Alrighty, everybody. As I mentioned, we're going to be starting off pretty close to the Earth. Not quite so. You can see the city lights start to pop up just down below. But we're going to be starting right here at this spacecraft called the International Space Station. We also like to abbreviate it as the ISS because it's kind of a long name. And a lot of people tend to ask me, hey, Christian, what is the International Space Station? I hear about it all the time in articles and news, but I don't really know what it is. Could you explain it for me? Well, of course, folks. The International Space Station is a research facility, a laboratory that orbits around our Earth. And they're able to conduct a lot of different types of science experiments that they would have trouble doing closer to the ground with a lot more gravity. Some of the different science experiments that they'll conduct up here are things like, what happens when you try to grow plants in space? Do the plants grow the same? Do they grow differently with less gravity? Which way do the roots grow? Another one is what happens when you try to spark a match in space? Does the flame act the same? Does that act differently with less gravity? And one of my favorites is where they had two identical twins. One twin lived on Earth for about a year, the other one lived on the International Space Station for a year. After that year, they compared and contrasted. Turns out when you live in space for a long period of time, you tend to age a little bit slower, but not only that, you also tend to lose a lot of muscle because you don't have gravity constantly working down on your muscles all the time. So if you plan to live in space for a long period of time, remember to exercise daily. And folks, the International Space Station looks really big here on our planetarium dome, but in actuality, it's not that big. It's only about the size of an American football field. If you've never been to an American football game, don't worry. You can also use the entire California Academy of Sciences, the museum we're sitting in. That's about how big it is. And what's also really fascinating is that the International Space Station is traveling incredibly fast. It's going a whopping 17,000 miles per hour, where it orbits once around the Earth every 90 minutes, where it experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. And also, folks, this thing looks really far away from our planet, but it's not that far either. The International Space Station is only about 225 miles above the surface of our world. 225 miles, that's like going from San Francisco to Santa Barbara, a nice little road trip to get away with the family for the weekend, so not too bad. And to tell you the truth, folks, this is as far as we put humans out into space nowadays, only about 225 miles. The reason why? Well, it's very expensive to travel into space. First, you got to build yourself a rocket ship or buy yourself one, and then you have to account for a lot of rocket fuel. You're going to need so much rocket fuel, you got to escape the Earth's gravity. Once you get all that rocket fuel, you have to account for all the food, water, and all the air you're going to be breathing while you're up here in space, so the bill gets quite costly quite rapidly. But folks, the International Space Station is just the first stop on our tour of the universe, so we're going to see it now start to slowly disappear. And before we lose track of the International Space Station, I want to add a nice little orbital path so we can see it as it slowly disappears to the city lights down below. So we'll see you later, International Space Station. Alrighty, folks, we've zoomed so far out now that we're looking down on our entire planet Earth. And I want to let you know, since we're out here, I want to tell you about the space program that I'm using here in the Morrison Planetarium. This is something that you can go home and download if you want to give it a try and fly through space just like how I am. It's a whole lot of fun. The space program that I'm using in here is something called OpenSpace. So if you go to your favorite search engine, type in OpenSpace Project, you'll come across a link where you can download it. But just a heads up, OpenSpace is not finished. It's in its beta phase, which means we may come across a few bugs and glitches. If we do, I'll point them out. Hopefully we can look past them. And also, folks, OpenSpace uses a whole lot of processing power. So if you've got an older computer, something that can't handle too much, I wouldn't recommend downloading it. But if you got something newer or a gaming computer, give it a try. It's a whole lot of fun. And if you're a person like me that doesn't want to download anything or just doesn't have enough space on their computer, because I never delete anything, well, we also have another great alternative called NASA's Eyes. Just like the human eyeball, just go to your favorite search engine, type in NASA's Eyes, and you can come across a link and you can fly through space. It's just so much fun. So we got OpenSpace Project and NASA's Eyes. But now that we got a good sense of what we're using here in the Morrison Planetarium, let's make our way over to our nearest natural neighbor to us in space, the moon. And to tell you folks, we humans have been to the moon before, but that was a little while ago. That was between 1969 and 1972. Thanks to NASA's 6 Apollo space missions, that brought a total of 12 incredibly lucky guys to walk on the surface of the moon. They got to conduct science, and of course, they had some fun up here as well. They got to play some golf. But again, the last time we sent humans to the moon was 1972, a little more than 50 years ago or so. But don't worry, folks. We humans are planning to make a return trip back to the moon in the next few years, thanks to NASA's new space mission in the works called Artemis. Pretty much with Artemis, NASA wants to send humans to Mars, but before we send humans deep into our solar system, we got to figure out the logistics of how we're going to be living out here in space. So the moon is the perfect stepping stone to figuring out all that stuff. And what's even more fascinating is that with NASA, they're going to be sending the first woman to the moon, but not only that, they're also going to be sending the first person of color to the moon, but not only that, they're also going to be setting up lunar bases throughout the moon. Pretty much our technology has greatly improved in the last 50 years, so we're able to conduct a lot more science in a much more compactable way. And one place that we want to set up a lunar base is the south pole of the moon. The reason why? Well, we found ice there, and that's going to be very helpful for setting up lunar bases. And maybe we want to go take a look at some other places on the moon that we weren't able to check out 50 years ago. Maybe we want to go take a look at some collapsed lava tubes. Maybe we want to go look on the far side at the deepest crater at Aiken Basin. Those are just a few places that we want to check out. And also, folks, if you want to see the rocket Artemis, it's going to launch this Saturday, depending on where you're at, so check your time. But they're going to be testing out the rocket system, and it's going to be traveling around the moon and coming back. It was scheduled earlier this week, but it was postponed due to some technical difficulties. But again, we humans should be heading to the moon in the next few years. I'm super excited. Look out for any news about Artemis. And folks, when we look up at the moon here from Earth, sometimes the moon feels incredibly close to us. Feels like you can reach out your arms and touch it. But the moon is incredibly far away. It's about 240,000 miles away from the Earth. Whew, 240,000 miles. Some of the adults in this room may have a car with that many miles on it. And if you take better care of your car than I do, you can even imagine driving to the moon if you drove for about 4 months nonstop, going about 80 miles per hour. Although I wouldn't recommend it, the roads out here are poorly maintained. Hee hee hee. And folks, from here on out, we're going to need to use a more useful measuring stick because at this scale, using miles is kind of like using inches to describe the distances between cities because space is so big. So astronomers use a more convenient measurement known as light speed. And light travels at a mind-boggling speed of 187,000 miles per second. That's roughly about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so ever since, it only takes light 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But at last, folks, it's time for us to leave the moon behind, so everybody say, bye-bye, moon. We'll see you later. Hee hee, so cute. And now, folks, we're going to see the moon and the Earth in their orbits as they start to slowly recede. In fact, before we lose sight of the moon, I want to add some nice planet trails because, again, space is so big, you can easily lose stuff out here. And folks, on our journey today, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to help of computer models like OpenSpace showing us the most accurate images and information available to us. And now the nearest star is in view. So here's that sun. Here comes the sun. Do. And also, folks, the sun is incredibly far away from us here on Earth. The sun's about 93 million miles away from the Earth. So again, we're the third rock from the sun. 1, 2, 3, 93 million miles between us. In order for sunlight to travel at a distance, it only takes sunlight about 8.5 minutes at the speed of light. So 8.5 minutes, that's not too bad. But now that we have a nice bird's eye perspective of our solar system, let's get a quick refresher of what's in here, shall we? Right in the middle is our star, the sun, the biggest thing by far. The closest planet to the sun, we've got Mercury. Then we have Venus and Earth, that's us. And then we also have Mars. These are the rocky terrestrial planets. These are places where we can actually land a spacecraft on. And then beyond the orbit of Mars, we have this really cool thing called the main asteroid belt. And this is what it would look like if we were to highlight all the asteroids in our asteroid belt. There is a lot of them. So there's those asteroids. And then past the asteroid belt, we have the really big planets, the gas giants, the Jovians. We've got Jupiter, the largest of them all. Then we have Saturn, famous for its rings. And then past them, we have our icy gas giants. We got Uranus, the funny one, and then we got Neptune. And of course, we can add everyone's favorite and lovable dwarf planet, Pluto. So here's the orbit of Pluto coming on screen on the left-hand side right over there. And a lot of people don't realize that Pluto hangs out here in this outer part of our solar system called the Kuiper Belt. And you're probably wondering, what's the Kuiper Belt? I've never heard of that before. Well, folks, the Kuiper Belt's going to be all this stuff. So the Kuiper Belt is essentially a second asteroid belt. What you're going to find out here are mostly icy asteroids and short period comets. Comets that don't stray too far away from the sun. They have a nice short period like so. And pretty much we came across most of these objects in 2006. Came across 400 of these objects. And the reason why, well, our technology greatly improved. We were able to have telescopes that are able to see much further away and much more dimmer objects. And that's the really cool thing about science, because as our technology advances, we're able to rewrite the stuff that we know. So who knows, in the next 10 years, where our telescopes are going to be, we might be able to find more stuff in our own backyard, in our own solar system, which is quite exciting to think about. But I want to put away the Kuiper Belt because that's just a whole lot to look at. And right now I'm going to be adding on screen some of the many different spacecrafts we sent out in the 1970s to explore our solar system. So now on screen we have the trajectories of Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2, and the latest of them all, New Horizons, which did a quick flyby of Pluto in 2015. You can see that interaction towards the top where Pluto is. Now, just to let you know, all these spacecrafts are all traveling fast enough to escape the sun's gravity and leave our solar system behind. But even the most distant of these robot adventures, Voyager 1, has not traveled as far as light travels in a single day. In order for sunlight to travel all the way out to the orbit of Pluto, it takes sunlight about 5 hours at the speed of light. 5 hours, also not too bad. But folks, let's leave our planetary scale behind us because now we're going to be heading into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us about 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. Alrighty, everybody. So again, 4 years at the speed of light just to reach the next star to us, Alpha Centauri. And Alpha Centauri is going to be on the right-hand side. You can kind of see a star kind of moving with us. So we're right in the center. Alpha Centauri is right over there. But 4 years at the speed of light doesn't really give you a good idea of how long it would take us humans to travel that distance. In order for us to travel that distance, folks, if you're getting a rocket ship today, left our Earth, made your way over to Alpha Centauri, it's going to take you about 8,500 years to cross that distance. Whew, and that's just a one-way trip. But folks, let's stop and consider whether humanity has made its presence known beyond our solar system because now we're going to be stepping inside something called the radiosphere. So again, we're now inside something called the radiosphere, and this represents the current limits of the most distant radio signals humanity has ever broadcasted or rather leaked into space. And it extends about 90 light years in all directions, emitting out from the Earth. Now, this first began in the early 1930s with strong radio waves, early television, radar signal, and then later the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. And humans were broadcasting well before that, but the earliest radio was not quite powerful enough to escape the Earth. And since all these signals are electromagnetic, they are traveling at the speed of light, so this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is always expanding at the rate of 1 light year per year. So is anybody out there listening? And right now, folks, I'm going to be adding some many markers onto the screen. These many markers indicate the thousands of stars astronomers have discovered over the last 30 years, which has at least one or more planets orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far today, we found 5,000 confirmed exoplanets in the nearby vicinity to us, 5,000 other worlds besides our own. And that 5,000 number is going to be increasing as the years continue because we have space telescopes where their whole purpose is to find as many exoplanets as possible. In fact, if we zoom out just a little bit, you can see on the backside of our radiosphere, on the right side, you can see a whole heap of exoplanets where our space telescopes just pointed their view in. So that 5,000 number is going to be increasing as they slowly continue to scan more and more of the night sky. Now, to say if any of them are Earth-like with conditions suitable for life as we know it, well, we cannot answer that question quite yet. Pretty much new space telescopes are being developed right now, so those are on the drawing board. It's going to be a few years before those are constructed, launched into space, conduct science. So we've got a little while before we can answer that question. But the more important point here is that quite a few of these planetary systems are within that 90 light-year limit of our radiosphere and could have potentially received our signal. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, the communication delays between hellos could be decades in time. Now, to give you an example, let's say we live in a star system on the far left side, right over here. We find an alien civilization somewhere on the right-hand side. We shoot them a text message. We say, hey, we live here. Take 60 years to get to them. They listen in, answer back, another 60 years. Folks, that is a 120-year conversation in the making. Whew. And I can barely wait for a text message from my friend. But of course, folks, planetary systems beyond the radiosphere, more than 90 light years away, have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. But for now, I'm going to be putting away the exoplanet markers. And I want to leave our radiosphere up on screen, because as huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way Galaxy. So keep your eyes on that radiosphere as we continue zooming out. folks, we're now looking down at our entire Milky Way galaxy. This is the galaxy that we live in, and I've got to ask you, can you see your house from here? Just kidding. We're way too far away. And folks, our Milky Way galaxy is incredibly large. If you wanted to cross it from one side to the other, it's going to take you about 130,000 years at the speed of light. Whew, that is a good distance. Not only that, our Milky Way galaxy is so huge, we estimate that there's at least 300 billion stars in our galaxy. If our recent discovery of so many exoplanets just within our small neighborhood within this vast star city is any indication, there could be billions of planets and potentially millions of Earth-like planets throughout our single galaxy. And before we leave our Milky Way galaxy, I want to show you what it looks like from a sideways perspective. You're going to notice that we live in a big flat spiral disk. Kind of looks like a pancake from a sideways perspective. And when you're looking up in the night sky, probably at night, you probably heard someone say, hey, look, you can see the Milky Way from here. Folks, what they're referring to is the Milky Way plane. That's where you're seeing up in the night sky. And that's also important because when astronomers and scientists want to learn about the universe, it's so much more easier for them to point their telescopes galactically north and galactically south instead of looking to the plane of the Milky Way, which has planets, stars, gas, debris, things that block their view of the universe. So again, keep that in mind. We like to point our telescopes galactically north and galactically south instead of looking through the plane of the Milky Way, which has a lot of stuff there. But folks, the Milky Way galaxy is only one of many hundreds of billions of galaxies that comprise the known universe. So in this giant leap, every single point of light that you're now going to see no longer represents a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. Now, we live in a local galaxy group, which contains about 30 galaxies, large and small. Also includes the nearest large spiral to us, the Andromeda Galaxy. Only 2 million light years away, just next door, and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And folks, as we continue zooming out, you're now going to realize that galaxies are not evenly distributed throughout space. Instead, galaxies like to clump together in large groups and clusters, or they like to avoid each other where there's very few galaxies or no galaxies at all. So we can see a nice galaxy cluster right in front of us, another one a little bit behind it. We can see very few galaxies towards the top or no galaxies at all. You can kind of think of galaxies like people. They like to hang out together or they like to avoid each other. And folks, we've zoomed so far out now that this picture that we're looking at represents the closest 30,000 galaxies to us in a space over 300 million light years across. We got to give thanks to an amazing astronomer by the name of Dr. Brent Tully, who worked at the University of Hawaii, who compiled this amazing representation from the work of dozens of other astronomers working aside him over decades of time. So big shout out to Dr. Brent Tully. And since we're all the way out here, folks, I want to show you the first image that was released by the James Webb Space Telescope, the biggest, most complicated space telescope we've ever put into space. It's the predecessor, or it's the telescope that came after the Hubble. And this is the first image that it released earlier this year. And folks, what we're looking at is something called the James Webb Deep Field Image. And this photo is spectacular because what we're looking at is a photo that occupies a really small portion of the night sky. If you were to pick up a sand grain off the floor, raise it arm's length up to the night sky, this is about the frame that you're looking at, only a sand grain in the night sky. And we're seeing hundreds of galaxies all in this one photo. And what's even more fantastic is that it's focused on a galaxy cluster, these really large bright points. And this galaxy cluster has so much mass that it's causing space and time to warp, creating this bubble effect. Can you kind of see the outline there? This is called gravitational lensing. So pretty much it's causing the background galaxies behind this galaxy cluster to warp, distort, and duplicate. So we can see some nice galaxy cluster down to galaxy distortion towards the bottom left. We can see some galaxy distortion on the right-hand side and then the top right side as well. And what's even more fantastic is that the James Webb Space Telescope took this photo in just about 12 and a half hours compared to the Hubble Deep Field image, which took 21 days. Folks, our telescopes are getting much more powerful, and I cannot wait to see what other images that will be releasing in the years to come. But let's get back to our tour of the universe, because now we have automated systems mapping even the most distant galaxies, folks. Now we're about to see the very large-scale structure of the universe. And remember, folks, every single point of light that you're seeing, that's not a star, that's an individual galaxy. Whew, I feel small. And just to let you know, the universe is not shaped like a bow tie or a butterfly. Remember when I mentioned that we live in a flat spiral disk of the Milky Way Galaxy? Well, if we were to line up our Milky Way, it would line up just down the middle like so. So again, we like to point our telescopes galactically north and galactically south instead of looking through the plane of the Milky Way. But astronomers still wanted to make sure that there was galaxies through the plane of the Milky Way. So we have this nice purple survey of galaxies right in the middle. You'll notice that they were still able to find galaxies, just not as many and not as far. Pretty much we have to wait for our technology to improve, and once that happens, we'll be able to map out all these areas that haven't been filled in yet. So it's just a matter of time. But folks, it looks like we're running drastically low on our tour of the universe. 30 minutes is just not enough time. So let's continue pressing on, because now we're going to be encountering these really distant, faraway objects known as the quasars, located at the very edge of the large-scale structure of the universe. So the quasars are going to be these orange dots. We got some quasars on the right side. We got some quasars on the left side. And quasars are short for quasi-stellar radio sources. These blazing objects are all billions of light years away, so now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe, and before there was a teenager, there was a baby. So let's press back to a time before quasars, before planets, stars, and even galaxies began to form. Folks, we're about to see the very edge of the observable universe. Alrighty, folks, here we are at the very edge of the observable universe, and what we're looking at is something called the Cosmic Microwave Background Image, or the CMB image for short. And all evidence indicates that the universe that we live in is about 13.8 billion years old. And this is data compiled by Planck and other radio telescopes. And this picture is a baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And this isn't a typical photo either. Instead, this is a temperature density image where the light echoes of the Big Bang are color-coded, with the lighter areas corresponding to the hottest, least dense regions, and the darker areas the coolest, densest regions. These fluctuations in temperature and density are extremely tiny. They vary no more than 1 part per 100,000. But these really small differences eventually gave rise to the large-scale structure of the universe that we saw moments ago, that clumping and clustering of galaxies everywhere. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, folks, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But folks, we traveled as far back as the law of physics can physically allow us to go, so we only have one direction left to go, and that's going to be back towards planet Earth. So let's find a nice entry point through all these quasars and galaxies. This one looks pretty good right here. And let's make our return trip back to planet Earth, y'all. Alrighty, everybody, we're crossing an expanse of over 13 billion light years. We present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. And we live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. And with that thought, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to look through their telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But it looks like we just made our way back into our Milky Way Galaxy. We're heading straight for that radiosphere. And of course, we're making our way downtown, walking fast, faces pass, and we're homebound. Da-na-na-na-na-na. And we're now approaching our solar system, folks. About to pass the spacecraft we sent out in the 1970s to explore it, passing the Kuiper Belt in the orbit of Pluto, making our way to the third rock from the sun, our homeworld, planet Earth. All the people that we know, everybody that we learned in history, all lived on this one planet. And it looks like we're about to pass the orbit of the moon, the furthest we've ever sent humans out into outer space. And folks, as we make our final approach back to planet Earth, this is going to be the end of our Tour of the Universe show. And I want to thank y'all for stopping by and watching it with me today. If you're traveling afar, you can watch this exact show on our YouTube channel at the California Academy of Sciences, or you can check out the Morrison Planetarium Facebook page and catch this show, and you can show your friends and family. But hey, folks, look at that. We made it back safe and sound to planet Earth, and that's all for now. And I want to thank y'all for stopping by.